In this video, I'm going to do an optimization problem using derivatives. So in this diagram, you can see that there is a semicircle which has a radius of r is equal to 5. We're gonna find out what is the biggest rectangle that we can fit inside this semicircle. So to do this, what we are gonna do first, we are gonna find the area of the rectangle. Okay, so let's say the area, and we are going to use it as a represent the area as a function of x. So this is your x, okay, this is also length is x, so the length of the rectangle is actually going to be 2x, and the height is y, right, which is this, so 2xy. Now in order to solve the problem, we kind of need to express y in terms of x. So look, this is a right triangle, right? So in this right triangle, so starting here, here, and here. So this right triangle has a hypotenuse of 5. So it's going to be 5 square is equal to x square plus y square. So this is y and x is this, using the Pythagorean theorem. Now if I solve for y, I'll get y square is equal to 25 minus x square, or y is equal to square root of 25 minus x square. At this point, I'm going to take this y and plug it in right here. So my a of x, area of the rectangle as a function of x, is going to be 2x times square root of 25 minus x square. Now we want to optimize. That means in our case, optimization implies finding the maximum area, rectangle with maximum area. So we need to take the derivative of it. So we need to find a prime of x, which is going to be, let's say, 2x times the derivative of square root of 25 minus x squared. So there's going to be 1/2 times 1 over square root of 25 minus x squared times, using the chain rule, negative 2x plus 2 times square root of 25 minus x squared times 1, the derivative of x. So let me just quickly break it down for you what I have done here. I have done a couple of things in one step. So I have used the product rule to take the derivative of it. So my u is 2x u, and my v is square root of 25 minus x squared. So u times the derivative of v. So square root of 25 minus x squared, the derivative of it is going to be the same as the 25 minus x squared to the power 1/2, right? Take the derivative of it because square root is to the power 1/2. If I apply the power rule, that's going to give me 1/2 times 1/2 times 25 minus x squared to the power 1/2 minus 1. Then use the chain rule, right, to take derivative of 25 minus x squared again, which is going to be just negative 2x. And that's going to give me 1/2 times 1 over, this is going to be negative 1/2, right, which is going to be 1 over square root of 25 minus x squared times negative 2x. And that's exactly what I have here. So my a prime of x is going to be equal to, so these 2 and 2 are going to cancel out, right? So that's going to give me negative 2x squared in the numerator, and in the denominator I'm going to have 25 minus x squared, and then I have right over there plus 2 times square root of 25 minus x squared. There is a bit of algebra here, so let me go ahead and do that. So if I kind of do the algebra, this is what I get. So I just simplify this, add this thing, and I do it by multiplying and dividing both this by square root of 25 minus x squared, and then combining and simplifying it. It's pretty straightforward, you can figure it out. Then if I go further, this is what I get. So and ultimately it comes down to 2 times 25 minus 2x squared over square root of 25 minus x squared. Now that's the derivative, and we want the derivative to be set to 0. And when is the derivative going to be 0? It's going to be when 25 minus 2x squared actually, minus 2x squared is equal to 0, or x is going to be 25 over 2 square root of it, which is going to give you x is equal to technically plus or minus 5 times square root of 2. But we are going to ignore the negative value of x because we are dealing with length here, and we want to stick to positive value, right? Length cannot be negative at this point. So it's going to be 5 times square root of 2. So that's my critical point, by the way, where the derivative is 0. So to look for the optimal, or in this case maximum value, we are going to look at the boundary points as well as this critical point. So at the boundary points, let's look at the function a of x. As you can see, there is a square root here, right? So x can be only between 0 and 5. So 0 is less than equal to x is less than equal to 5, because if it's more than 5, then we are going to have negative number under the square root. That gives me complex numbers, which we are not going to be dealing with in this problem. So let's look at the value of this function a of x at 0, the boundary point. So a of 0 is going to be x is 0, so the whole term becomes 0. How about a of 5 at the boundary point? If x is 5, then 25 minus 5 square, which is 25, which is 25 minus 25, 0. So that's also 0. And now I need to evaluate at this value. So I need to find a of 5 over square root of 2. That's going to be 2 times 5 over square root of 2, 2 times x, this, times square root of 25 minus 5 over square root of 2 whole square. So that's going to give me a of 5 over square root of 2. So then 2 times 5 is 10 divided by square root of 2. Then square root of 25 minus 25 over 2. That's going to give me 10 square root of 2 times square root of 25 over 2. Okay, so square root of 25 over 2. That's going to give me 10 times square root of 25 is 5 over square root of 2 times square root of 2, which is 50 over square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So your a of 5 over square root of 2 is going to be just 25, which by the way happens to be r square or 5 square. So the rectangle with the biggest area or the largest area contained within this semicircle will have an area of 25 square units, which is 5 square. And if you look at the radius, which is 5, so you can actually say it's just r square. I hope that this discussion was helpful. Thank you very much.